Greetings of the day, dear students. And in this video, we are going to discuss about the RMS or effective value. Dear students, before watching this video, please complete watching the peak value, peak to peak value, instantaneous value, and average value concept. Then only you can understand this RMS or effective value. Clear? Yeah. Now, in this process, finding out the effective or RMS value for a given periodic waveform, right? Let me first define that. It defines it states that the effective or RMS value of periodic current is nothing but the DC current that delivers the same average power to a resistor as the periodic current. The statement looks simple, right? But you have to understand it properly. How do you understand this? Effective value of a periodic current is the DC current that delivers the same average power to a resistor as periodic current. In a simple manner, I will tell you. For example, in this circuit, if you are applying some alternating quantity, right? You have applied a waveform like this, sinusoidal quantity, and for example, if this peak value is 311 volts, and some current will be flowing through the resistor, right? And some power will be delivered to the resistor. For example, let me assume some 100 watts is delivered to the resistor. Now, if you apply some DC voltage in order to get the, I should get the same 100 watt delivered to the resistor, then at that time what should be the value of the DC voltage, or that value, DC value? If it is sinusoidal, you are clear. If it's some 311 you are applying and some 100 watts is delivered, right? Now in order to deliver the same amount of power, same average power, how much DC you have to apply? That value of DC indicates the effective or RMS value of a given sinusoid. Do you know, to get the same amount of 100 watts without deriving the derivation, shall I tell you what is our RMS value? RMS value, VRMS for a sinusoidal, VRMS value is Vm by root 2. After doing all the derivation, we will see that RMS value is how much for a sinusoid? Vm by root 2. Its meaning is, by simply applying some 220 volts here, if a DC of 220 volts is applied, then you will get the same effect as if a sinusoidal of 311 volts peak value. That is the meaning. Vm is already known. Vm is how much? 311 whole divided by root 2. That much value of DC you have to apply to deliver the same average power to the resistor. Same 100 watts is to be delivered. Like that you have to understand. So indirectly, if you observe, with less amount of DC, you are getting the same effect of AC. Same effect of AC. Otherwise, to get the same effect of AC, the DC voltage is only 220 volts is required. Enough. 220 is enough. You can deliver 100 watts to the resistor. Right? Yeah. Now let me see the that is what the meaning. Right? Yeah. Now let me see how to find out that value. To find out the I effective that will transfer the same power to the resistor as a sinusoid, the sinusoidal representation we know, Im sin of omega t. But for AC circuit, what is the power? Average power. In both the cases, you find out the average power. Of course, everybody know that power P. You know that power P already you have completed the DC circuits. Power P equals to, immediately you will tell me VI. Right? Yeah. Average power you will get by integrating the power over the time period 1 by t, integrating the power within the limits 0 to t 1 by t I square of t into r dt. And r is a constant value, take it outside and let that one be the equation 1. Now if the same current is flowing in the DC circuit, that value of current, when both the powers will be equal, that current is the effective value. Let you denote it as I effective square, I square R. Power P equals to VI over R, I square R over R, V square by R. V square by R. Now I effective square into R. Just simply equating 1 and 2, I effective square into R is the power, average power in DC and the average power in AC, sinusoidal. R get cancelled. So I effective equal to root over 1 by t integral 0 to t I square of t dt. Very, very important. That is what the meaning of root of mean of square of RMS. Root of mean of square of. Right? So this is the root mean square value. Next one is in the place of phi of t we will write the mathematical form. Now for symmetrical waveform, the RMS value can be found by considering the half cycle or full cycle. But for unsymmetrical waveform, full cycle must be considered. You observe here effective value. Now some V effective equal to 1 by t integral 0 to t V square of t dt. What is the maximum value? In the place of V of t, what you can write? In the place of V of t, based upon its from graphical representation, the mathematical form is 311.2 sine of omega t. That is what you have written here. You take its square, 311 square sine square of omega t d omega t. But what about sine square theta? From trigonometric basics, sine square theta equals to 1 minus cos 2 theta whole divided by 2. That is what you have done here. 1 minus cos 2 omega t whole divided by 2. All these things we are doing derivative with respect to the omega t. Now observe, you take out 1 by 2 common, integral of 1 omega t, and within the limits 0 to 2 pi, integral of cos at, integral of cos at, how much you will get? Integral of cos is sine at and whole divided by a. That is what you have done here. Integral of cos 2 omega t is sine 2 omega t by 2. The limits are 0 to 2 pi. Clear? These basics are important. If you know these basics, you can easily do that. Two simple basics are required. Sine square theta equal to 1 minus cos 2 theta by 2, and the integral of cos at is sine at by a. Simple, right? So just you apply the limits, upper limit minus lower limit, 2 pi minus 0, sine of 2 pi 0, sine 0 is again 0. This entire term becomes 0. So that is the reason why here minus 0. So on simplification, 311 square by 2 we got. But what is 311 in our context? Maximum value Vm square by 2. We just separate root over Vm square by 2, root of Vm square Vm by root 2. Very, very important here, students. If you are having a sinusoidal of the form V of t equals to Vm sin omega t, its RMS value is Vm by root 2. Vm by root 2. Effective or RMS value. Two basics are required. Sin square theta equals to 1 minus cos 2 theta by 2, and integral of cos at is sin at by a. Remaining things are very easy. Next. That is about the effective or RMS value. Now let me find out the form factor and peak factor. These two definitions a number of times you will be asked in the mid exams, or sometimes in problems also we have to do that. Form factor simply RMS value by average value. RMS value by average value. The ratio of RMS value to the average value is nothing but the form factor. Now if you observe, for sinusoidal, form factor is already you have seen RMS value is VRMS is how much we got. Some VRMS is Vm by root 2. 1 by root 2 is nothing but 0.707 times Vm, and average value, some V average value, how much we got? 2 times Vm by pi, right? 0.637. Already we have seen in the previous derivation. Let me observe. Two times Vm by pi. 2 times we have seen the derivation. 2 times Vm by pi. That value is 0.637. This is 0.637 times Vm. Vm here in this context is the maximum value. So if you take the ratio of these two, 0.707 into maximum value divided by 0.637 into the maximum value, you will get 1.11. Very, very important. Form factor for sinusoidal. RMS value by average value. RMS value derivation we have seen. VRMS is Vm by root 2. Average value we have seen the derivation. 2 times Vm divided by pi. Just simply substitute. You will get the form factor as 1.11. Right? Yeah. Now, again we have done the derivation here. That's it. Just we have to make you understand how we got this 0.707 for a half cycle within the limits 0 to pi Im sin theta, and integral of sin theta is minus cos theta within the limits 0 to pi, right? 2 times Im, that is the area of half cycle. That is just area only. Now to get the average value, 1 by t times integral 0 to half. This area we got it as 2 times Im. Now it is simply 2 Im by pi. If it is current. If it is voltage, 2 times Vm by pi. That's it. Just in the place of current, you will write the voltage. 0.637. If it is a negative half cycle, the average value will be minus 0.637. If you consider the total cycle, the average value will be 0. Now similarly, the RMS value for half cycle, 1 by t by 2 integral 0 to t by 2, half of the time period, Im square sin square theta. Observe, again sin square term we got here. We will simply write it in the form of 1 minus cos 2 theta by 2. Just simply we are expressing sin square theta in terms of 1 minus cos 2 theta by 2. Right? And we are applying the limits. On simplification, we will get Im by root 2. Just like Vm by root 2, we will get here Im by root 2. Now 0.7071 times Im. Now we want the form factor. Ratio of both. RMS value we got as 0.707 and average value 0.637. So the form factor is 1.11. Very clear? Good. Now observe, dear students, if it is sinusoidal, okay. If it is some other waveform which is not a sine of omega t format, then how to find out the form factor? Such kind of questions are also possible in the exam to be asked. Then the thing is, they will give you the graphical form, but most of the students feel very difficult to express the mathematical form in graphical form. This graphical form in mathematical form. You will be given the graphical form, But if I ask you to apply integral for this waveform, will you do like this? Can you do integral of like this? Will you take? We have to apply integrals. No. Is it possible like this? No. You should know its mathematical form. What will be its mathematical? This is graphical. Then what is its mathematical? That derivation you should do. For example, if this is the graphical mathematical form, now you will say V of t equal to Vm sin of omega t is the mathematical form. But for such kind of waveform, what is the mathematical form? We have to derive, right? Yeah. Now, dear students, when waveform is given, don't think it will be very difficult to do that problem. Just the only thing, the secret is you first find out its mathematical form. If you observe, first let me say form factor is the ratio of RMS value by average value. Form factor is the ratio of RMS value by average value. What will be the average value? If you observe, this is the triangle. Triangle is like this. It is in the form of a triangle. This length is 2 and this length is 12. Now we can easily tell half into base into height will be the area. Average value is area whole divided by time. Half into base is 2 into height is 12. The time period is, observed for this waveform, capital T is 2. Clear? So the average value is 6. Very simple. The average value is 6. Now we want to find the RMS value. Observe 1 by t, the definition for RMS value, this one you should remember, 1 by t integral 0 to t v square of t dt. Here the student feels very difficult. In the place of b square of t, what you have to write? You know the graph, but you don't know its mathematical form. This is the graph given. This is the graph given. Very simple, dear students. You just find out the line equation. Enough. Equation of this line. What is the line equation? Y minus y1 equal to slope m into x minus x1. The line is like this. This coordinate is how much, dear students? 0, 0. What about this coordinate? X-axis length is how much? On x-axis you are having time 2. What is the y-axis length? 12. 2, 12 is your second coordinate. So simple. This represents x1, y1, and now this represents x2, y2. Now simply express in the form of a line equation. Y minus y1 equal to m into x minus x1. But in our case, at last, in the place of x-axis, we are having time. In the place of y-axis, we are having v of t. That's the only difference. For understanding sake, you express in terms of y and x at the starting stage. Later, you remove. In the x-axis place, what you will get? T. In the y-axis place, what we will get? V of t. Very easy. But the thing is, you have to find out the coordinates. These coordinates. For understanding sake, I have written x1, y1, x2, y2. But in our case, what is x-axis, dear students? Time. Y-axis is voltage. T1, V1. T2, V2. Like that you have to understand. Clear? Yeah. Now, if you express in the form of equation, you will get V of t equals to 60. This is the mathematical form for the given graphical form. This is given as 12 and this value is given as 2, and this is our voltage waveform V of t, and this is our x-axis time. So nothing but a line passing through origin you got. If somebody asks you slope, opposite side by adjacent side, opposite side is 12 divided by adjacent side is 2, 60. Very, very important. If you know this one, the entire problem is very easy. V of t equals to 60. V of t equal to how much, dear students? 60. Now very easy, in the place of v square of t. Now v square of t represents what? V square of t will be how much? Is 36 t square. That is what you will do here. Within the limits 1 by t, 0 to t, v square of t dt. 1 by 2 integral 0 to 2 36 t square with respect to dt, you will do the derivative. Sorry, integral. Integral of t square. Integral of t square is how much, dear students? T cube by 3. That is what you have done here. T cube by 3 within the limits 0 to 2. So you will get 6.9282. 6.9282 is the RMS value for the given waveform. For this given waveform. In the entire process, you will feel difficult. Most of the students looking at the waveform, they are facing the difficulty how to write it in the mathematical form. Right? Yeah. Average value they are finding out easily. Average value, because they know the it is in the form of a triangle. Average value half into base into height they are doing, and they are dividing it with time, and they are getting the average value correctly only. Most of the students are doing it correct. But most with respect to the RMS value, here they are struggling. V square of t. This is the procedure how to find the V of t value. Once you know the V of t value first, V square of t is easy. Just taking the square of that. Okay. Yeah. Now its form factor is RMS value by average value, 6.9282 by 6, 1.1547 is the form factor. Clear? Yeah. Next topic is the peak factor, and some textbooks you can see it as amplitude factor or crest factor or peak factor. It is simply the ratio of maximum value to the RMS value. Maximum value to the RMS value. In this form, in the given sinusoidal, I of t equal to Im sin of omega t. Dear students, maximum value is how much? Maximum value is Im, and IRMS, just now we have seen the derivations, is RMS value is Im whole divided by root 2. If you take the ratio of these two, it represents the peak factor or crest factor. We are not asking peak value. Peak value is Im, but he is asking peak factor. Observe, peak factor, not peak value. If it is peak value, Im, simple. The simple answer is Im. Peak factor, maximum value by RMS value. It is 1.414. Similarly, for this example, now you can tell me the peak factor, maximum value. If you observe in this waveform, what is the maximum value reached? 12. And RMS value, just now we have seen 6.9282. So the peak factor will be maximum value divided by RMS value. 12 divided by 6.9282. It is 1.732. 1.732 is the peak factor for given waveform. Clear? Yeah. Now, dear students, let me summarize all the important aspects with respect to the sinusoidal waveform. The waveform is given like this. Its positive value is 311.2 plus Vm, minus negative peak is minus 311.2, right? Its mathematical form is V of t equals to 311.2 sin of omega t, and V of t equal to Vm sin of omega t, right? And its peak value Vm is 311.2. That is what we have written here. Peak value is Vm, Vp. Peak to peak value 2 times Vm. 2 into 311.2 is 622.4 is the peak to peak value. Instantaneous value at some particular instant. Here I considered at omega t equal to 30 degrees. Right? So at omega t equal to 30 degrees, in the place of omega t just substitute 30. So 311.2 into sine 30. This represents the instantaneous value. Now the average value for the sinusoidal 2 times Vm by pi. 2 Vm by pi. 2 into 311.2 divided by 3.143. You will get 198.027. Right? And RMS or effective value, VRMS, this derivation also we have seen, Vm by root 2, Vm by root 2, and you will get 311.2 divided by root 2, 220. That is the reason I have taken 311.2. What is the, for our households, what is the voltage we will get? 220 volts. Now tell me, this 220 represents which value? If nothing is specified, if simply they are saying V equal to 220 volts, they are not telling this is which value. They won't tell. If nothing is specified, by default it is RMS value. Very, very, very important. That value indicates which value, dear students. In any problem, they won't say specifically it is an RMS value. Simply they will say a voltage of 220 volt. How do you understand that value? Out of these many values, is it a peak value or peak to peak value or instantaneous value or average value or for which value? That doubt should come to your mind. If nothing is specified, by default that value is, you should consider it as RMS value. It is an RMS value. Clear? Yeah. Now 220 volts AC supply, we will use that word. So that 220 represents the RMS value. Yeah. So form factor, RMS value by average value for sinusoidal only 1.11, and with respect to the peak factor, maximum value by RMS value, you are getting it as 1.414. 1.414. So this is what all about the summary of different terminology. Summary of the different terminology. Okay, students, you should clearly understand the meaning of each and every word. If in the given problems, if anything is asked, you should be in a position to answer them. First, understand the differences, right? And with this, we will conclude this topic. Okay. So, dear students, please share this app with as many students as possible, and please share with you will be having so many friends in different colleges. Okay, and please share this link to as many students as possible of your friends in different colleges. Moreover, a number of times I am telling, only 50% of the students are passing this subject in the first attempt. If your seniors are also having this subject as a backlog, please share to your seniors also, and please support this, encourage this one. Thank you.